Imagine a material engineered for a single terminal purpose: to intercept a fatal chemical attack, absorb the damage, and destroy itself so that the metal beneath it can remain whole. This deliberate act of chemical sacrifice happens silently across our cities every day, protecting the steel infrastructure we rely on to function. This is the hidden role of element 30, zinc, represented here by these small metallic pellets scattered across its place on the periodic table. Physically, zinc is a standard bluish-white, lustrous metal, but its true value is found in its high reactivity, a specific chemical readiness to attract corrosive elements to itself before they can reach other materials. Because of this property, zinc serves as the ultimate metallurgical bodyguard. Modern cities are built on a foundation of iron and steel. Look at the skeletal framework of these early skyscrapers. Without this metal, we could never have built upward. We see the same dependence in transportation. On assembly lines like this one, steel car frames are welded into the rigid, safe structures that carry us every day. But these materials have a fatal flaw. When exposed to the oxygen and moisture in our atmosphere, they begin a steady, inevitable process of corrosion. As rust eats into these bridge beams, it destroys their structural integrity. Left unchecked, this process creates a multi-trillion-dollar engineering hazard for our global infrastructure. Without an active, reliable shield against the elements, our bridges and buildings would require constant, unsustainable repairs to prevent catastrophic failure. To stop this decay, engineers use a process called galvanization, coating the vulnerable steel in a protective layer of zinc. This cross-section shows the strategy in action. When oxygen and water molecules approach, the zinc layer stands in the way, acting as a bodyguard for the steel below. Because zinc oxidizes more readily than iron, it pulls the corrosive reaction toward itself. The zinc layer takes the hit, corroding away while the underlying steel remains untouched and structurally sound. Even if the coating is deeply scratched and the steel is exposed, the protection doesn't stop. The surrounding zinc will sacrifice its own electrons, flowing into the bare iron to prevent rust from forming. Zinc is not a passive barrier, it is a sacrificial chemical shield that dies so that our steel can live. This concept of sacrifice and protection extends from the world of giant machines down to our own biology. Zinc is an essential trace element. Our bodies require it in precise, appropriate amounts to manage the constant internal and external stresses we face. At the cellular level, zinc acts as a defender. By embedding into specific receptors, it helps maintain normal immune function, shielding ourselves from harm. It also drives essential biological machinery behind the scenes, serving as a catalyst for DNA synthesis and enzymatic reactions that ensure normal cellular growth and division. The same element that stabilizes a bridge is fundamentally required to protect human health. We find this protective element locked within the earth. Zinc is rarely found in its pure metallic form in nature. Instead, it's typically extracted from minerals like sphalerite ore. This vintage processing facility shows the massive scale of the effort needed to meet our global demand. We move millions of tons of earth to recover this one essential metal. Through high-heat refining, workers separate the pure zinc from the raw ore. This glowing molten metal is the final product, ready to be deployed across the world. Beyond galvanization, we use zinc to create brass alloys, in die casting for precision parts, and as seen in these dry cell batteries, to power the electromagnets that drive our technology. We have now learned to harness this metal's unique reactive profile to build a much more durable, energized civilization. Every time we cross a bridge like this, we are witnessing the silent, sacrificial work of zinc. It is the material that holds the modern world and our physical bodies together by being willing to face the attack first. We often celebrate the materials that survive the longest, but sometimes the most important material is the one that takes the hit so another doesn't have to. The periodic table reveals the architecture of our existence. It is the story of the universe. To learn more about the hidden stories behind the elements that build our reality, subscribe to Atomic 118. Join us as we explore the next chapter.